In our previous video, we were looking at the sum of a very specific arithmetic progression, namely the sum of first n natural numbers. So this was an arithmetic progression with the first term as a and the common difference d as 1, and we saw that the sum would be equal to up till n terms. This would be equal to n. Well, I'll write n as k terms because I'll use n later on. So first k terms of the first k natural numbers, the sum of it would be equal to k into k plus 1 over 2. We derived this in a previous video, and the result is actually a very familiar one, but the derivation was quite interesting. Now we are interested in the sum of a general arithmetic progression, the sum of any given arithmetic progression. So any given, I'll abbreviate it as AP. Well, first of all, how would the AP look like? A general arithmetic progression. The first term, let us say that it's A. The second term will be A plus some common difference. I'll call it D in our case. And the third term will be A plus yet another D. Well, A plus D, which is A plus 2D. The fourth term is A plus 3D. And we want to go up till n number of terms. So the nth term would be, well, the first term was A plus nothing, A plus 0D. Second term was A plus 1D. The term number 3 was A plus 2D. Term number 4 was A plus 3D. So term number n would be A plus n minus 1D. And we are interested in finding the sum of this arithmetic progression. Well, first of all, we see that the addition operation we have is commutative, and hence we can shuffle around the terms, and we could group all the a's together, a plus a plus a plus a, and this will go on up till n times because there are n a's in our sum, and plus will have 0d, which I'm not going to write, plus d plus 2d plus 3d plus 4d plus 5d, and all the way up till n minus 1d. So we have n number of terms here too. And now let us take, because we see that d is common to all of these terms, well, first of all, the first term would become, the first group would turn into n into a, because that's the definition of repeated addition is multiplication, and plus will have a d common to everything, so it will be d times 1 plus, well, 2 times d is 2d, so 2, 3 times d is 3d, so 3 plus 4 plus n minus till n minus 1. Well, now conveniently enough, we have already derived the sum of natural numbers up till k terms, which is equal to this thing over here, and we see that we have n minus 1 terms this time. So what does this simplify to? D times, well, n minus 1 in place of k. Where there were k terms, the sum was k into k plus 1 over 2. Where there are n minus 1 terms, the sum would be n minus 1 times n minus 1 plus 1, which is n again, over 2. So this would be n times, or n minus 1 times n over 2. And you might pause the video if you like and convince yourself that I have substituted n minus 1 into this formula in place of k. So well, now what do we have? We have an equation for the sum of arithmetic progression, the whole sum we had up here, in terms of a, d and n, and it's just an explicit formula. So we are done with this derivation. But in our books usually we see it in another form, and this might seem very this is not required actually, and this might seem so, but I'll still take an n common, and I'll write this as a plus d times n minus 1 over 2. If you take n common, this would be the answer, because you can verify this by distributing n again into the brackets and you get back this, so you can verify that. And I'll also take a 1 by 2 common. So 1 by 2 times n, which is n by 2. And since I'm taking a half common, so what times a half would give me a? So 2 times a half would give me a. So that will be the coefficient of a plus, and we do have a half there. So this will be just d into n minus 1. So this step, this formula you will find in a lot of textbooks, and this is given as a sum of an arithmetic progression, but we could have stopped here. Why we did 2 extra steps, and this mystery would be solved in the next upcoming few videos, because there's actually an explanation for this, and everything would fit in there. So I hope you understood, and thank you.